Okay, anyway, let's start. Good morning, everyone. I hope you had a good night and a good breakfast and some good coffee. Let's talk about the missing link, Mockless unit test. It's a thing I discovered some time ago when writing embedded firmware, and I thought I'd like to share that because it's something about the software quality assurance chain for embedded devices, which I think is missing something which maybe I discovered, and I called that Mockless unit tests. Okay, a few words about me. I've been doing that for a while and currently working as a software quality architect. So my responsibility is everything having to do with software quality when it comes to embedded device, embedded firmware development. And that's also how I discovered this thing about the missing link. So what's all this about? Let's begin with some simple questions. First question, how do you make sure your C++ classes and functions work as expected? And we all know that you write unit tests and you run them regularly on developer machines and CI servers, and you forbid merges when the unit tests don't pass, all that stuff. I hope you have something like that in place. That is just very, very simple stuff. How do you make sure your C++ functions work on the target platform? Quite a different question, especially when talking about embedded devices, where the target platform is a lot more restricted than your development platform. And the answer is to run the unit tests on the target hardware. Because you may have a different word size. You may have 16-bit ints on the target platform, but 32-bit ints on the developer platform and the CI platform, or you may have a different endianness, different stack size, different restrictions when it comes to dynamic memory, number of threads, or whatever. So it's important to run all your unit tests on your target hardware. There was talk about that in last year's emBO. It's very important to do that. It's not as easy as it sounds, unfortunately. It can be quite challenging, but you should do it anyway. Now, how do you unit test functions that use something that only exists on the target platform? Thinking about stuff like special hardware, which doesn't exist anywhere outside your target device, or special operating system APIs, or anything that makes the target platform different from the development platform. And yeah, that's not a difficult question either, because everyone knows how to write mockups, fakes, or dummies, which is essentially a software layer which makes your functions, your C++ functions, the ones you are testing, believe they're running on the target hardware, but in fact they're not, just running on the CI and accessing the mockups and not the real thing. You have to do that, because how else are you supposed to test something that exists only on the target platform? Well, but doing all the mocking, how do you make sure your C++ functions interface correctly with the hardware operating system of the embedded device, since you mocked away those interfaces? And yeah, also a question that has been answered before, and the answer is to write an integration test, which looks at your device from the outside. You see, unit tests look at the device from the inside, and the integration tests look at a complete device with the hardware and operating system and everything, including your firmware, from the outside, using some public APIs to test stuff. Okay, you should be doing that also. It's a completely different layer of testing, of course. With a unit test, you look into C++ functions and go on a very low layer, but integration tests are on a very high layer, but then they can test the real thing, which the unit tests cannot because of those mocking layers. So how do you make sure your C++ functions properly use things that only exist on the target platform? And well, it sounds like I'm asking the same stuff over and over again, doesn't it? But there is actually a difference here. And that's getting us closer to my point, actually. The difference is, okay, so we have some stuff on the target device, which we use in our code, and we want to check if we're using it correctly, and so we use a mockup. Okay, so the mockup has to be realistic in some way, and then we can test against the mockup, and then we have the old stuff on the real device, and we can do some integration tests. But how do we make sure that the mockups are actually realistic enough? Um, just let me give you an example. This is some real life code taken straight out of my latest development project. Um, this is a this is part of a C++ interface for the OpenWRT libuci library. In case you know OpenWRT, it has this thing called UCI, which is sort of a configuration file management thing, and it comes with a C library called libuci, and we are using that in our code. And it's a C library, not quite easy to use, easy to get wrong, poorly documented. So the idea is to have a very simple C++ interface around it. And with very simple, I mean very simple to use. The interface itself is quite complex because it hides away all the libuci stuff inside this C++ layer, and applications can then use UCI in a very simple way and not in a complicated way of the libuci C library. And this gives us code like this, just a small excerpt from my code. And some of the symbols are in bold, all those that begin with UCI, and these exist in platform builds only. And now, to write a unit test for that code, of course, I have mockups or fakes or stuff for those UCI symbols. But the big question now is, am I using these UCI functions correctly? And that's a big question because they are quite easy to use incorrectly. It's easy to mess stuff up. And in the worst case, you would mess up your device's configuration. In the very worst case, you would brick the device. And the mockups don't really replicate all of that. You see, they just provide some simple interface. But how do I know that my mockups really behave in a sort of bug compatible way like the real thing? Okay, that is the question that I was asking myself when writing this code. And the big question now is, how do I test this code? Well, I could write unit tests, of course, but no, that will not work because in the unit test, I've got the mockup layer. I'm just testing against the mockups. But I want to know if I am using those functions correctly. Mockups won't help me answer that question. Integration tests, when no, they cannot directly access the C++ classes or functions, they can just access that indirectly by looking at things from a very higher level. This is not what I want to do in my test. I want to go down on the C++ level, on the unit level, actually. So integration tests are completely the wrong way. Okay, so then I can do those on-device unit tests. But actually, no, that will also not help me test that code because, and that's the crucial point here, the on-device unit tests, they also use the mockups. They're just the regular unit tests built for the device and executed on the device. And they also use the mockups. They just test against the mockups. I don't want to do this. I want to test with the real thing. So on-device unit tests, although they're very helpful for other things, will not help me a bit here. And that is where I think I found a missing link. I found something that is not possible in the common chain of having unit tests and integration tests. And the missing link is something that I call Mockless unit tests. I want to do unit tests with all the functionality I have in a unit test. I can dig directly into the C++ classes and member functions and everything, just like I can with regular unit tests, but I want those to really access stuff on the device. I want unit tests that can work with the real libuci library on a real embedded device, not with some mockups, but still be a unit test with all the unit testing facility I have. And that is what I called Mockless unit tests. And that is actually how I solved my problem. And yeah, here's how I did it. First, the Mockless unit tests are separate from the regular unit tests. Okay, so you have two things that are both called unit tests. One is the regular one, and one is the Mockless ones. I'm using the same unit test framework for both. It's not strictly necessary, but it will make your work a little bit easier. But the Mockless unit tests do not use any mockups or fakes or dummies or stuff like if-def unit tests or whatever, but they just use the real thing because they run on a real device. They use the real thing, use the real operating system APIs and everything, just like the regular platform builds. The Mockless unit tests will build and run on the target device only. They will not run on the CI server. So they are more part of a firmware build than part of a CI build. And you normally cannot execute them during a CI pipeline unless you have a real device connected and can communicate with the device during a CI pipeline. If you can do that, congratulations, then you are doing a very great job, but sometimes that may not be possible. Speaking of running those Mockless tests on the device, actually they use the same technology as the on-device unit tests. So once you've figured out how to run your regular unit tests on the device, you're halfway there to implementing Mockless unit tests because the technology will probably be very similar. And a general rule of thumb is you should use regular unit tests whenever you can and Mockless unit tests if you must. So if you have a choice of testing something in a regular unit test, you should test it there. You should only test in the Mockless unit test if it cannot be tested in the regular unit test. For example, because you want to test if things really cooperate properly with this UCI library or whatever you have on the device, which does not exist on the regular unit tests. And once I figured that out, I found out that was not a new idea after all, but that I had been doing those Mockless unit tests for quite some time. I have a big C++ Linux server application, which is database oriented. So it does quite a lot of work with a database. And when I wrote the unit tests for that system, I figured out well, I have to write some unit tests for a database application. How do I test that? And the classic approach would be to mock away the database. Okay, because classically unit tests don't have any outside dependencies. So you put in a mockup layer, which kind of checks if the C++ code of the application produces the expected SQL commands, which are then sent to the actual database in the real application. But the question is, how do we check if those SQL commands actually work against a real database? And that was so crucial for my application. So years ago, I decided to use unit tests that don't mock anything, but that run against a real database. So my unit tests required a real database with everything that comes with it, all the difficulty or the reentrance issues, or the runtime issues. So the unit test ran for a very long time. And I always had kind of a bad conscience about that because I thought, well, I'm not doing unit tests right. Everybody knows you're supposed to do mockups in a unit test. I'm not doing that. I was quite shaky about that. But now that I have a name for these things, yes, I kind of achieved some peace of mind with that because I'm saying now, okay, I'm doing Mockless tests. What's the problem? That is a good way to do it. So those Mockless tests are important or useful not only for embedded platforms, but probably for some other stuff also. Okay, finally, let's talk about a practical example, some real-life experience where I use this. This is also where the code example I mentioned before comes from. I was working on the firmware for the Devolo Magic PLC adapters, you know, these little things that connect your network devices over the power lines. Some of you may even have those devices in your home. I have at this moment, you see they work. They don't always work, but they work for me. You see, this is how I'm connected to the internet now. And these things have an embedded Linux based on OpenWRT applications written in C++. We're using Boost Test as the unit test framework. And all those applications are OpenWRT packages. If you're familiar with OpenWRT, you probably know what I'm talking about. And the Mockless unit tests also are another OpenWRT package, which is built and installed on the devices as part of the regular firmware build, which has a special developer or nightly mode, which builds a firmware which contains the Mockless unit test program and also the on-device unit test program. So they're both deployed as part of the regular nightly tests. In the production firmware, they are not contained, of course, but we do that on the developer firmware, and it's tested automatically as part of regular daily integration tests. We cannot run it as part of the CI pipelines for various reasons, and but we do it automatically anyway as part of integration tests, and this is how we are doing it for those PLC adapters. And yeah, not much to see. This is a screenshot more or less of how this thing works when you run it. So we SSH into the device, we run user bin itests, which is what the Mockless unit test program is called. And yeah, you see some progress output. This is created by the Boost test framework. And you see all the tests passed, just 5 test cases so far. And as I said, everything that can go into regular unit tests should go into regular unit tests, only put into the Mockless tests what needs to go into the Mockless test. So there's only 5 test cases so far. And in the best case, you get the output of no errors detected. So all the tests have passed. So you know you haven't broken anything. Okay, and that's it. Are there any questions? Okay, no questions. That means everybody's very satisfied or everybody's fallen asleep, which I would perfectly understand given the circumstances. Anyway, thanks a lot, everyone, for watching, and have a nice day. See you next time.